Let us consider unit number 6 related to the design of prestress concrete beams for flexure. Mainly consider the rectangular sections. So what exactly given data as well as what you have to find out. Okay, so let us concentrate on the given data. Okay, bending moment due to dead load as well as bending moment due to live load, permissible stresses, under transfer and working load conditions of beam, and last one material properties. What you have to require to find out? Required to calculate, okay, cross sectional dimensions, that is width and depth of beam. Next is prestressing force, capital P, then area of tendon and eccentricity of tendon. These things you have to find out. Let's move through the one by one step how to design the beam for the flexure. Okay, so first consider step number 1. If the bending moment of beam due to dead load and live load is not given in question, you have to find out bending moment due to dead load and live load. Okay, so bending moment due to dead load is MdL is equal to dead load WL square by 8 if the beam is simply supported. Bending moment due to live load is equal to live load into L square by 8 when beam is simply supported. Next is you have to find out the minimum sectional modulus. Okay, calculate numerical value of minimum sectional modulus Z. Okay, how it is calculated? So Z bottom is equal to, the related formula is bending moment due to live load plus 1 minus mu into bending moment due to dead load divided by FBR. Okay, and Z top is equal to, if beam is unsymmetrical, Z bottom and Z top is having different value. So bending moment due to live load plus 1 minus mu, okay, MDL divided by FTR. Okay, we know that for symmetrical section Z top and Z bottom is having same value, whereas mu is equal to loss ratio. Okay, then what is the meaning of FBR? FBR is the bottom fiber stress range. Okay, so this is the bottom fiber stress range. Okay, how it is calculated? So FBR is calculated considering this formula, mu into FCT minus FTW. Okay, so mu is the loss ratio, FCT and FTW are the permissible stresses under transfer and working load of the beam. Then FTR is the top fiber stress range. Okay, how it is calculated? So FTR is calculated using this formula, FCW minus mu into FTT. Okay, all these formula for FTR and FBR, Z top and Z bottom are derived for considering the permissible stresses and minimum sectional modulus and critical loading condition of dead load and live load. Let's concentrate on what is the exactly meaning of FCT, FTW, FCW, FTT. Okay, write down where FCT is equal to permissible. So this is the permissible compressive stress, permissible compressive stress under transfer stage, under transfer stage of loading, under transfer stage of loading. First letter is indicated the nature of the stress, and second letter is for the stage of the loading of the beam. Next is FTT. This is a permissible tensile stress, permissible tensile stress for transfer, FCW is the permissible compressive stress, for working load condition. FTW is the permissible tensile stress for working load condition. Okay, so we know that for the rectangular section, Z is equal to Z top and Z bottom. It is 1/6 of BD square. After calculation of Z top and Z bottom value, you have to equate this calculated value with 1/6 BD square. Assume width of the section and find out the depth of the section. Next, step number 3, calculate actual stresses for top and bottom fibers. Actual stresses for top and bottom fibers. So how the top fiber stress is calculated? So this is FTT minus MDL divided by Z top. Okay, and how the F bottom is calculated? Okay, FTW divided by mu plus bending moment due to live load plus bending moment due to dead load divided by mu of Z bottom. Okay, once you get the F top and F bottom, then calculate actual values of bending moment due to dead load and bending moment due to live load, considering the actual values of B and D. Finally, step number 4, calculate prestressing force. Calculate prestressing force P using this formula. P is equal to A into F bottom into Z bottom plus F top into Z top divided by Z top plus Z bottom. Okay, and last step, step number 5, calculate the eccentricity. Calculate the eccentricity of tendon. Okay, calculated as eccentricity E is equal to Z top Z bottom into bottom fiber stress minus top fiber stress divided by area of the section Ft Zt plus Fb into Zb. Okay, where the capital A is the cross sectional area of the concrete. So these main 5 steps you have to follow for design of prestressed concrete rectangular section.